This is about arithmetic sequences. They start with an initial term and they add a common difference d each term. A plus D, A plus 2D, A plus 3D, A plus 4D, and so on. For example, 1, 2, 3, 4, 5, etc. starts at 1. The first term is 1 with a difference, common difference D of 1. Or 2, 4, 8, 2, 4, 6, 8, 10, 12, 14, 16, and so on. That starts at A equaling 2 and common difference D of 2. In general, the nth term of an arithmetic sequence will be A plus n minus 1D. This n minus 1 puzzles a bit, but think about it. If A1, we have at A1, this cancels out and just get A1 equals A. So this n minus 1 is to offset this being A being the first term. If you had an A plus ND, then you'd have to start it with A0. All right, here we go. So with AN, 5 halves minus n minus 1. What's the first term? Well, it's this, 5 halves. What's the common difference? -1, because -1 times n minus 1. First 5 terms are easy to find. You start off with 2.5 and subtract 1 each step. 2.5, 1.5, 0.5, -0.5, and -1.5. All right. Here we have an arithmetic sequence, 21, 13, 5, -3, and so on. What's the common difference? What's A5? What's AN? What's A100? Okay. Well, if you take the difference 13 minus 21, that's -8. 5 minus 3 is also -8. -3 minus 5 is also -8, and that's good. They should all be the same. So, okay, common difference is -8. First term is 21. So the nth term is first term A1 minus common difference minus 8 times n minus 1. 21 minus 8 times n minus 1. That's the nth term. And by plugging in, A5 is -11, A100 is -771. Let's do the same thing for this sequence, starting at -12 and going -8, -4, 0, and so on. All right, well, if you take -8 minus -12, that's 4. -4 minus -8 is 4. 0 minus -4 is 4. Each one is 4 bigger than the one preceding. That starts at -12. So we have A plus n times D times n minus 1. -12 plus 4 times n minus 1. So plugging in 5 for n, you get 4. Plugging in 100 for n, you get 384. Here we have a sequence where A1 is 1, D is 2. So these are odd numbers, 1, 3, 5, 7, 9, 11, 13, 17, 15, 17, 19. Find the sum of the first 10 odd numbers. Sum as n goes from 1 up to 10 of an. All right, so initial term is 1, the common difference is 2, an is 1 plus twice n minus 1. So if you add them up, 1 plus 3 plus 5 plus 7 plus 9, 11, 13, 15, 17, 19, it comes out to 100. In fact, in general, the sum of the first n odd terms is n squared. That's actually something we'll be proving later on. So here we have initial term is 5, common difference is 4. What's the sum of the first 20 terms? All right, so I just plug it in. 5 minus 1 is minus 4 is 1. Minus 4 is -3, minus 4 is -7, minus 11, minus 15, minus 19, minus 23, minus 21, minus 31, 27, minus 31, 35, 39, 43, 47, 51, 55, 59, 63, 67, and minus 71. If you add them all up, you get -660. Now, there's a general formula for an arithmetic sequence. So we have a sequence A plus K times D times K minus 1. Then the sum of the first n terms, A plus D plus A plus n minus 1D, turns out to be, right? Here's the easiest formulation. It's a number of terms times the first plus last over 2. In other words, the average term. So it's the number of terms times the average term. If you plug in the numbers, you plug in this expression for an, you get n over 2 times 2a plus n minus 1d, whatever. Now here we have, okay, classic sequence of that sort. Add the numbers from 1 up to 100. Okay, there's a story told about Friedrich Gauss, one of the greatest mathematicians, well, the greatest mathematician of the 19th century. As a very small child, he was in the schoolhouse, and the school teacher wanted to keep the kids busy. So he told them to sum up the first numbers, the numbers from 1 to 100. All the other kids were busily scribbling on their slate boards, and of course they all got it wrong eventually. But young Gauss, 6, 7 years old, he thought about it for a few seconds, wrote down the answer, and said, "There it lies." And the answer is simple. You take the average of 1 and 100, 1 plus 100 over 2, times the number of terms, that's 100. 100 times 1 plus 100 over 2 is 5,050. And he was right. And the school teacher was astonished that the kid just could think about solve this by just thinking about it. Later on, young Gauss corrected his father's accounting sums. That was the point where they realized they had somebody special. But never mind. Okay, here we have 1 plus 5 plus 9 all the way to 400. What is that? Well, first you can check out it's a difference of 4. And if you work it out, it's 101 terms. So the sum will be 101 number of terms times the average term, 1 plus 401 over 2. And after a bit of work, it's 20,301. All right.